Students, this short video is to introduce the concept of inverse functions. First of all, every time we talk about inverse functions, the fundamental premise is that the functions must be one-to-one. So we can talk about inverse function. What is a one-to-one function? Well, just like the name states or implies, for each input, for different inputs, we'll have different outputs. We just a traditional quote-unquote partner of marriage. In this example, this very simple example, -2 goes to -8, 1 goes to 1, 2 goes to 8. This would be, of course, the domain of the function. This would be the range. So there's nothing funny here. We are not sharing domains, ranges from the domain. So for, this other example that I have here, this is not one-to-one. It is a function, but it's not a one-to-one function. Means that 1 goes to 1, that's good. However, both -2 and 2 goes to 4. So this is a function, but it's not one-to-one. On the contrary, this one is one-to-one. Just FYI, if you notice what we are doing here is using based on these only 3 examples that we have here, what we're doing is we are cubing. We are raising to the cube the number. -2 multiplies by itself 3 times will be -8. 1 cube, 2 cube will be 8. In this case, f of x equals x cubed. On this one, we're just using these 3 examples. This is f of x equals x squared. What it does, it takes the input and squares it. -2 squared, of course, is 4. 2 squared is 4. This is what is not one-to-one. Given 2 inputs, they share the common output. Like the square of 1 is just 1. But this is the problem that is sharing an output versus here, we are not sharing an output. Okay, so what is the definition of inverse? As I said, we must start with a one-to-one function. So let f of x be a one-to-one function. Then the relation, what we call relation is the pairing, the mapping, the arrows, the relation from an element y in the range of f of x back to an element x in the domain of f of x is called the inverse function of f of x. Notation f inverse of x. It's not that we are raising to a -1. It's not that we are taking the reciprocal. This is just a notation f inverse of x. It's not f to the -1. No, it's f inverse of x. So as a definition, let me read it again. Let f of x be a one-to-one function. Then the relation from an element y in the range of f of x back to an element x in the domain of f of x is called the inverse function of f of x. Notation f inverse of x. If you need some more time, you may want to pause the video for a while you've. I have a very simple example here to illustrate all of that blah, blah, blah that we had here before. So just using these 6 pairs, we can tell definitely that the function is one-to-one. Notice that -2 relation -8, -1 to -1, 0 to 0, etc., etc. Exploring the numbers, you can tell that what we're doing, we are cubing the numbers. -2 cubed, that will be -8, or multiply by itself 3 times. -1 cube is 1, -1, 0 to 0, cube of 1 is 1, cube of 2 is 8, the cube of 3 is 27. So what we're doing, we are going f of x equals x cubed. Notice that the numbers on the left, these are the domain, the set of numbers. This is the domain of f of x, its input. And of course, here on the right-hand side, we have the range of f of x. Now, what does the inverse say? It says, well, the relation from an element y in the range of f of x back to an element x in the domain of f of x is called the inverse function. So it's like, okay, we're going backwards. And in this case, of course, the f inverse of x will be the cube root of x. So if you notice, of course, the cube root of negative 8 is negative 2, cube root of negative 1, negative 1, 0, 0, the cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3. Moreover, this is very important, folks. Notice that if I'm moving from left to right, so just use this black route, that will be your function f of x. This is the domain and this is the range. However, if I go from right to left, following the red road, which is namely the cube root of x, notice that now these numbers become the input and these numbers become the output. So that's one of the properties of inverse functions, that the range, first of all, the range, which is the output of this case, the black function f of x equals x cubed, becomes the domain of this other function, the red function, f inverse of x equals cube root of x. So this will be bigger. Inverse function of x equals cube root of x. Likewise, the domain of the original, or the f of x, becomes the range or the output of the red one. So this will be the range. So there are three main properties of inverse functions. So let's go ahead and write down two of them. Because of the fact that we start in point A, we take a little road, we land in another place, and then we take the road back and takes me to the original starting point. I just take a long road, then it takes me back to my original point. Like pressing the GPS, give me the reverse directions. So that concept is what we do here when we do f of f inverse of x equals x. When we do the GOF and the GOF, both pairs should give me x. And f inverse of x equals x. If you recall, when we practiced with the composite functions, I gave you two examples in which when we did the pair, both answers were equals to x. That means that we could conclude that those two functions were inverse functions of one another. So this is property number one. And property number two, we have it here, that the range, the domain of one function is the range of the other, and vice versa, the range of one is, likewise, the range of one is the domain of the other. So the domain of f of x equals range of f inverse of x. Likewise, the range of f of x equals the domain of f inverse of x. And the third property deals with the graphing, the graph of both functions. And we'll talk about that in a few. Okay, folks, so this is what we have so far. So f of f inverse of x equals 2x. Also, f inverse of f of x equals x. And the domain of one is the range of the other. So we are going to see two main type of problems in this portion of the section. Problem number one, or typical problem would be determine if the two functions are inverse of one another. Okay, so that's the type of question. Given two functions, are they inverse? Yes or no? So given two functions, comma, are they inverse of one another? So in this subsection, we're going to find two types of questions as I was saying before. So the first type of question would be, given two functions, are those two functions inverse of one another? Yes or no? Yes, they are. No, they're not. Or given a one-to-one function, find its inverse. So this is a yes/no question. This is what f of f inverse equals blah. So here we just have to decide yes or no. And here we need to find the actual inverse of x equals blah, 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 blah. So yes or no. It's a yes, no answer. So how do we attack the first type of questions? Well, if you recall, this one we said, well, we just have to find the composites of the two functions, and they better be x for both of them. So f of f inverse of x must be equal to x, and f inverse of f of x must be equals to x as well. For example, here, okay, in the book, this is a type of, given the two functions, we need to prove that the composite of the functions equals to x. F inverse of f of x equals x. Likewise, f of f inverse of x equals x as well. For the second type of problem, how to find the inverse, we need to apply the process of finding the inverse, which is as follows. Where are you? Okay, there you go. Okay, so we need to replace f of x with y, interchange x and y. So for y, I replace y with f inverse of x. So this will be the process, these 4 steps, and we'll go from there. So let's go ahead and do 2 examples of each, and we'll go from there. Let me stop sharing this. So this is what we have. Given two functions, are they inverse functions of another? Yes or no? Here I attempted to write, the approach will be finding f of f inverse of x and f inverse of f of x. Oops. Anyway, so let's see what we have. So let's go ahead and say f of g of f, because we still don't know if these are inverse of one another. So let's say we need to do the fog and the golf. So let's go ahead and start with the fog of x, which is f of g of x. Here we need to find, as we learned before, this case f is my outside function, g is my inside function. So the f function states 2/3 times input minus 4. 2/3 times input minus 4. But what is the input in this case? That would be g of x. So we go ahead and plug in 3x plus 12 over 2. That's the actual composition. Now we can simplify. Notice that, of course, we can simplify. This is going to be 2 times 3x plus 12 over 3 times 2. So 2 over 2 simplified. So what do I have? Oops. This is minus 4. I forgot the minus. So this is equals to that. Minus 4. Okay. Forgot the minus. So here, 2 over 2 simplify. So what do I have? 3x plus 12 over 3 minus 4. We can just do here divide and conquer. That would be 3x over 3, that would be x. 12 divided by 3, that would be plus 4. Minus 4 equals x. So we just did divide and conquer. 3x over 3, that's just simply x, plus 12 over 3, that would be, of course, 4. So that would be x plus 4 minus 4 equals x. So let's go ahead and find the GOF, the g of f of x. This is going to be g of f of x. Now, g is my outside function. F is the inside. So g says 3 times input plus 12 divided by 2. 3 times the input plus 12 divided by 2. But what is the actual input? The f function, that will be 2/3 x minus 4. Okay. So what do we have here? Let's just go ahead and distribute the 3. Let me just write it a little bigger. This is 3 over 1 times 2/3 x minus 4 plus 12 over 2. We distribute this. 3 times 2, that's 6. 1 times 3 is 3. So it'll be 6 divided by 3. That will be, or 3 over 3 will be 2x. And I distribute this. 3 times negative 4, that will be minus 12 plus 12 over 2. Last time we checked, of course, negative 2 plus 2, that's 0. So this will be 2x over 2, which is equals to x. Okay, so we found a pair of functions that when we do the composite, the answer is x for both of them. So we may conclude that these two functions are inverse of one another. So one of them, of course, can be called f inverse of x, and we're done. Or we can just call this one g inverse of x. And that's it. So we did prove that the functions are inverse of one another by doing the composite of the two functions. Let's try another example. Let me do a sharing of the. Okay. Go ahead and share the screen. This is what we have. So I have here two, we can do two more examples. In your textbook, let's try number 55, perhaps. We did 54, something very similar. And we can even try number, where am I? I got lost. Number 56. Okay. Let me write it down. Let me just do 56 first. Since we don't, in theory, we don't know the answer yet, I'm going to call this other one g of x, because I don't know yet if they're inverse of one another. Okay, so let me stop sharing the screen. And then we'll do number 55. I will not share the screen, I'll just write the program. Okay, so this is what we have. So what do we need to do? We are proving if these two functions are inverse of one another. So we need to do the f of g of x and g of f of x. On the first instance, f is the outside function, so it's my dominant function f. F is the input with cube, and then we subtract 5. Cube minus 5. But the input will be the g function. So we input here the cube root of x plus 5. Cube root, bye-bye. So here in the parentheses, we have x plus 5, the radical goes out, minus 5, the answer will be x. 50% done. Let's see what happens when we do g of f of x. Now my g is the dominant function. The g function is the cube root of x plus 5. What do we plug in here? We plug in the f function that will be x cubed minus 5. 5 minus 5 is 0, so this is simply the cube root of x cubed, which is equals to x. Therefore, they're inverse of one another. So now we can say that this POPI can be written as inverse of x, and we're done. Let's do another one. Which one I was going to do here? Let's try number 5. This f of x equals 1 minus x over x, and the other one 1 over x plus 1. Hopefully I have time space here. Okay, so let's go ahead and try this one. Perhaps you're gonna try it to see what you get, and we'll go from there. Okay, if you did not pause the video, let's go ahead and do this one. Notice that f of x has 1 minus input over the input. It's going to be a little bit fun. It's going to be 1 minus x over x. But what is x? 1 over x plus 1. You see the g, 1 over x plus 1. So that's the actual composite. We are very, very familiar with this type of problems. Of course, what we need to do, this is a complex fraction. So we need to multiply by what? We multiply by the least common denominator to convert the complex fraction to just a simple fraction. So let's go ahead and multiply by the LCD, top and bottom. The LCD in this problem will be what? The LCD will be x plus 1. So we proceed to multiply by x plus 1 on top. Oops, x plus 1 here, x plus 1 here, x plus 1 and the one there. So let's see what type of damage did we make. X plus 1 times 1 is just simply x plus 1 minus, here this over this cancel will be minus 1. X plus 1 over x plus 1, that will be 1. So what do we have? X plus 1 minus 1, that will be x over 1, which is just simply x. Oh, it was going to be more difficult. Okay, so that's that. One way halfway done, let's go ahead and try g of f of x. My g function is 1 over x plus 1. Now instead of x, we need to plug in f of x. So in this case, will be f of x will be 1 minus x over x. Okay, once again, what do we have here? We have a complex fraction. So one way of attacking this problem is to multiply by x everywhere. Multiply by x here, x here, x here. Oh, do it again. Multiply by x here, and x there. So let's see what type of damage did we make. 1 times x is just simply x. In the denominator, what do we have? X over x by so is 1 minus x plus x. But x minus x is 0, so this will be x over 1, which is just simply x. So once again, we got two functions. When we did the composition, the answer was equals to x. And that this POPI can be called f inverse of x, and we are done. Okay, not bad. Okay. The second type of problems is finding the inverse functions. And how do we find the inverse function? The procedure is straightforward. So of course, we need to assume that we start with a one-to-one function. So let f of x be a one-to-one function. So what do we do first? We replace f of x with y. Step 2, we interchange x and y. We flip them. And then Step number 3, we solve for y. Last but not least, once y has been isolated, that y will become f inverse of x. So let's start with the first example. It's a linear function. This is 1-to-1. F of x equals 4 plus 7x. Step 1, replace f of x with y. So f of x becomes y equals 4 plus 7x. So y equals 4 plus 7x. Interchange x and y. So we just, wherever we find the y, we write the x. Where we find the x, we write the y. And here we need to solve for y. Y is here by itself. If I were to isolate the y, what do I need to do with this 4? We can subtract, so it'll be x minus 4 equals 7y. Last but not least, we can divide by 7 to isolate the y. So therefore, y equals x minus 4 over 7, and we're done. So guess what? This is my inverse function, x minus 4 over 7. And we're done. That's all it is. If you do the composite, this and this one, the answer better be x. If you plug in this guy inside here, the answer will also be x. Anyway, so this is where it's not clear over there. So this is my inverse function. This guy, x minus 4 over 7, done. Let's try another example. The next example, f of x equals x cubed plus 5. So let's go ahead and start. This is, of course, 1-to-1. Let's replace f of x with y. Equals x cubed plus 5. We swap x and y, so x equals y cubed plus 5. We need to solve for y. If I want to leave y by itself, perhaps we can subtract 5. X minus 5 equals y cubed. How do I get rid of the cube? By just simply cube rooting left and to the right. So we just cube root. Cube root, so what do I have? Y equals the cube root of x minus 5. And we are done. This is your inverse. And now we need to replace y with f inverse. So this is it. So the f inverse will be the cube root of x minus 5. And we're done. If you want, we did something similar a couple of minutes ago. We play this guy inside here. The answer will be x. You place this guy inside here. The answer will be x as well. Another example, let's see what we have here. F of x equals 2 over x plus 5. First step, y equals 2 over x plus 5. Second step, swap x and y, so x equals 2 over y plus 5. And here we need to solve for y. So let me just rewrite this guy. X equals 2 over y plus 5. Okay, we have a fraction. By now, we better know that the LCD, if we want to solve, we should multiply by the LCD left and right. And here, y of that is eliminated. So we have here, let me just rewrite what we have. Y plus 5 times x equals 2. We are solving for y. At this point, folks, we have two options. One option will be to divide by x, and then we subtract 5, and we're done. It will be 2 over x minus 5. Done. Boom. Okay, I repeat, you divide by x in both sides. You have 2 over x equals y plus 5. You subtract the 5, so 2 over x minus 5 equals y, and you're done. Beautiful. Done. Move on. Or we have another option, which is to distribute the x, and then you solve for y accordingly. What I'm going to do, I'm going to distribute the x, because in some cases we can divide by x, just like I explained before. In some cases, you have to multiply, you have to distribute the x. So not to create confusion, when can I divide, when can I distribute? Just distribute all the time and problem solve. If you have something like this, just distribute. Boom, 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 and let's see what happens. So we have x, y times x, that will be xy. 5 times x, that will be plus 5x equals 2. Since I'm solving for y, this 5x is in my way. So xy will be 2 minus 5x. And solving for y, no big deal, we just simply divide by x. So therefore, y equals 2 minus 5x over x done. That is my inverse function. 2 minus 5x over x. If you do the other one, that will be correct as well. 2 over x minus 5. Okay. Let's try another example. Let's try this one. This is the example that we better not divide by x. We better distribute, just like we did the previous example. So I'm going to do this one kind of quickly, the first steps. You can follow me. LCD. Here, this step, I decided to distribute the x, because if you were to divide, you have to subtract by 5, add 5, and then you have to divide by 4 again. So you'll know with a complex fraction. It's better just to distribute, and might as well distribute all the time. So 4y times 6 for xy minus 5x equals 3. We may add 5x 3 plus 5x, or 5x plus 3, doesn't matter. And since we need to solve the y, we just simply divide by 4x. This way, this by, so we are done. Therefore, y equals this guy. So the inverse function, the inverse function is 3 plus 5x over 4x. And we are done. One more. Yeah, let's go ahead and do the last example. Again, the function is 1 to 1. Now, this is a little bit more elaborate. Notice that I have x in the numerator and the denominator. So let's see what happens. Same old, same old. Now we need to swap the x and the y. X equals 5y plus 1. Sorry, 2y. 2y plus 1, 5y plus 3. And we need to solve for y. So we have x equals 2y plus 1, 5y plus 3. We must multiply by the LCD. So far, so good. It's all the same. 5y plus 3, 5y plus 3. Yeah, this over this bye-bye. So we have 2y plus 1. And same old here, we need to distribute. It will be 5xy plus 3x. So now what do we have here? Notice that now we have two terms that contain the y, two terms that do not contain the y. No big deal. What we need to do is just to put all the terms that contain y one side of the equation and the rest on the other side. So here it's almost the same. We may subtract 2y. We may subtract 3x. So let's just go ahead and move all the terms that contain y to the left, everything else to the other side, to the right. So we have 5xy minus 2y. No, we subtract 2y. So we go this way, and the 3x goes that way, equals 1 minus 3x. Why do we do that? Why do I want to have all the terms that contain y one side of the equation? Because now I can factor the y. If I were to factor the y, so what do I have here? 5x minus 2. First, I put all the terms that contain y one side of the equation, and then I factor out the y. 5xy, so the y goes out, so that would be 5x, minus 2y, the y goes out, so it will be minus 2. Okay, 5x minus 2 equals that. And yes, you guessed it, so now we can divide by 5x minus 2, 5x minus 2. Therefore, y equals 1 minus 3x over 5x minus 2, and that's my inverse function indeed. 1 minus 3x over 5x minus 2, done. Okay, now it's your turn to try to find the inverse function. So let's see what we have.